Now, just a little bit of review from our class discussion. You can measure angles in other ways besides degrees. So the other way that we're going to be measuring our angles is in radian measurement. Now, a radian is a measure of an angle in standard position whose terminal side interrupts an arc of length r. So this length is r, which is exactly the same as the radius. So this is called 1 radian is the measure of that angle. So because the circumference of the circle is 2 pi r, there must be 2 pi radians in a full circle. So that would also mean that 360 degrees is equal to 2 pi radians. Or if you divide both sides by 2, 180 degrees is equal to pi radians. So let's convert some radians to degrees to radians. So I'll start with 45 degrees. If I start with 45 degrees, I want to multiply that by a form of 1. So all I'm doing here is just dimensional analysis. Pi radians is equal to 180 degrees. So because these two are the same, numerator and denominator, I'm multiplying by 1. So 45 degrees times pi would give me 45 pi over 180, but I did some reducing here first. 45 goes into 180 4 times, so I end up with pi over 4 radians. If I have negative 100 degrees, I start with negative 100 degrees. Again, I'm going to use dimensional analysis. Pi radians is the same thing as 180 degrees. And I can do some reducing here. 20 goes into 105 times. 20 goes into 189 times. So I end up with negative 5 pi over 9 radians. 574 degrees, dimensional analysis again, pi radians over 180 degrees. And if I divide both of these by 2, 180 divided by 2 is 90. 574 divided by 2 is 287. So I have 287 pi over 90 radians. Now let's go the other way. Let's convert the radians to degrees. So I have pi over 3 radians. I'm going to multiply that by a form of 1, which is just 180 over pi radians. And you see I have the radians on the bottom here because my radians were in the numerator here. So when I use the dimensional analysis, my unit is no longer going to be radians, it's going to be degrees. So this is equal to, let's see, 3 goes into 180 60 times, and pi over pi is 1, so I get 60 degrees. Negative 5 pi over 6 radians, I want to multiply that by a conversion factor of 180 degrees over pi radians. And 6 goes into 180 30 times. Pi also reduces, so I end up with negative 150 degrees. Negative 7 pi radians, I want to multiply it by a conversion factor again. 180 degrees over pi radians, and I can do some reducing. Pi radians over pi radians is 1, and 7 times 180 is 1260, and I want to remember that's a negative. So negative 1260 degrees. Now I want to remind you about the unit circle that we discussed in class. You want to make sure that you understand your unit circle and that you understand where all the measurements are coming from. So if you haven't already done this, make sure that you copy this into your notebook so you can use it for reference. And you need to be familiar with a couple more vocabulary words. A sector is a region of a circle that is bounded by 2 radii and an arc of a circle. And a central angle is an angle formed by two radii. So if this is my circle, here I have a radius and another radius. This is my arc length when I go from here to here. That's my arc length. Here's my angle theta. And this entire angle, or this entire region, is called a sector. Now, the arc length is represented by S, is this formula. S is equal to r theta. The area of the sector is A is equal to, or the area is equal to 1/2 the radius squared times theta. And what you have to remember is that theta has to be in radians when you use this formula. That's a big deal. So if you're given an angle in degrees, you're first going to have to change that. So it's going to be in radian measurement to be able to use these formulas. So here's an example. Find an arc length and the area of a sector with radius 10 inches and central angle 45 degrees. First thing I need to do is convert the 45 degrees to radians, because my formulas aren't going to work unless I have theta in radians. And remember, here are my formulas. S is equal to r theta, and area is equal to 1/2 r squared theta. So if I have 45 degrees, I want to multiply that by my conversion fact, which is pi radians over 180 degrees, and that simplifies to pi over 4 radians. Now I can find the length of the arc. So S is equal to r theta. The radius was 10, and my angle was pi over 4, which ends up being 5 pi over 2 inches exactly. The area of the sector is 1/2 radius squared times theta in radians. So that would be 1/2 times 10 squared times pi over 4, which would give me 25 pi over 2, and that would be square inches. Make sure you label these. The length is always in units, area is always in square units. Now, these formulas are really small, but they're also really easy to not to remember. They're really easy to forget. So here's another way that you can always do these problems and you don't have to remember the formulas. In fact, you don't even have to have theta in radian measurement. You could have theta in degrees if you want to use this method. What you want to do is just use a proportion. And I want to think of everything as part over the whole. I do want to remember my circumference. Circumference is equal to 2 pi r, and that's how I get the whole circumference. So to show you that I don't need to use radian measurement with this, I'm going to use the 45 degrees. And I'm going to think of, for my length of the arc, my part of the degree is 45 degrees over all the way around a circle is 360. So that would be equal to the part that I'm trying to find, this is the length of the arc, over 2 pi r. So that would be 2 pi times 10. So when I solve for x, product of the means is equal to product of the extremes. I get x is equal to 900 pi over 360, and that would simplify to 5 pi over 2 inches, which is the same thing I got up here when I use the formula. I can use the same approach when I try to figure out what is the area of the sector. I want to think about part over the whole, and I can do this in degrees. I don't have to have it changed to radians. So I have 45 degrees is my part, 360 is all the way around the circle. The area of the sector is just the part of the circle that I'm looking for. And I want to remember that area of a circle is pi r squared. So pi times 10 squared. When I do product of the means equals product of the extremes, I get x is equal to 4,500 pi over 360, which simplifies to 25 pi over 2 square inches, which is the same thing that I got over here when I used the formula. So if you can't remember the formula, you are not out of luck. You just want to make sure that you set up proportions. Just think of it as the part over the whole, and know your circumference formula, know your area formula.